Coming to irrational numbers, a number that cannot be written in the form of P upon Q or A upon B, where A and B are integers and B not equal to 0, are called irrational numbers. The sum, difference or product of or quotient of rational and irrational number is also an irrational number. We have seen 2 plus root 3 is an irrational number. Similarly, 2 into root 3 will also be an irrational number. 3 root 3 upon 2 will also be an irrational number. Decimal representation of rational numbers. What makes the rational and irrational numbers different in terms of decimal representation? If I represent a rational number P upon Q in the form of decimal, the prime factorization of Q, that is the denominator, will always be in the form of 2 raised to the power A into 5 raised to the power B. That means every rational number will have a denominator or terminating denominator in the form of 2 raised to the power A and 5 raised to the power B. See, every rational number can have a terminating as well as a non-terminating decimal representation. Here we are talking about the terminating decimal representation. So, if a rational number has a terminating decimal representation, the denominator will always be a product of the power of 2 or 5 or 2 and 5. That means either the denominator is a power of 2 or a power of 5 or both. If it is not a power of 2 or 5 and both, suppose the denominator is 3, 1 upon 3. 1 upon 3 is a non-terminating decimal. So, this property will help us to solve many questions and solve many MCQs. Let us see. 0.35, it's a terminating decimal. And how only by observation can I say that it's a terminating decimal? Because the denominator is 100 and 100 can be expressed as a power of 2 and 5. Similarly, 18.75 has a denominator 100 which can be expressed in the power of 2 and 5. 0.375 can again be expressed with a denominator 1000 and 1000 can be written as a power of 2 and 5 and so on. So that we see that the prime factorization of the denominator of all these rational numbers which has only the powers of 2 or 5 or both are terminating decimal numbers. If P upon Q is a rational number such that the prime factorization of Q is not of the form 2 raised to the power A into 5 raised to the power B, where A and B are both positive integers, then the decimal expansion of a rational number does not terminate and is recurring. So, this I have already told you that any rational number can be expressed either in the form of terminating or non-terminating decimal numbers. Let us look at this with the help of an example. Suppose I take 3 upon 10 and if I divide 3 by 10, I will get 0.3 which is equal to, and how do we know that? Because 10 can be expressed as 2 into 5. But if I write 3 upon 7, let us see whether will I get a terminating decimal number. Will the division come to an end or not? If I divide 3 by 7, it will be 0.42. Yes, 0.474 is a 28, 8, 5 and so on, and the repetition will take place after some time. Let us take it further. So, it will be 7, 1, 4, 2, 8, 5. So we see that the repetition comes after 1, 2, 3, 4, 5, 6 digits, and it will go on. Why was this recurring, or why the repetition took place? Because the denominator cannot be expressed in the form of powers of 2 and 5 or 2 or 5. So this was a very interesting property which we'll see will be very helpful. The key points that we have learned from here: a number is called a rational number if it can be written in the form of P and Q or A upon B, where A and B are integers and B not equal to 0. A number is called an irrational number if it cannot be expressed in the form of A upon B. The sum difference product of a rational and an irrational number is also an irrational number. Like the example which we have seen, 2 plus root 3 is also an irrational. 2 into root 3 will be irrational, and root 3 upon 2 will also be irrational. Rational number are of two types depending on whether their decimal form is terminating or recurring. If a rational number is terminating, then we have seen that the denominator will either be a power of 2 or 5 or both. Co-prime and the prime factorization of Q is in the form of 2 raised to the power A into 5 raised to the power B. If P upon Q is a rational number such that the prime factorization of Q is of the form 2 raised to the power A into 5 raised to the power B, where A and B are positive integers, then the decimal expansion is called terminating decimal expansion.